So I have an Ampzilla in for repair, and it does have an indicator that shows that it's on. Got a couple speaker fuses up here, headphone jacks for dynamic or electrostatic, and an on-off switch. So if I turn it off, you can hear the sound quits. Turn it on to get audio. There's supposed to be a couple of meters up here. So if I shine a light through them, you can actually see that they have needle pointers. And it shows 200 watts RMS into 8 ohms. But no matter where I put the audio input level, even though it's probably only 5 or 10 watts, I get no meter deflection whatsoever. And I get no illumination on the meters whatsoever as well. So let's go ahead and pull Ampzilla apart and see what's going on inside. So I've got this kind of turned on inside. Let me tip the camera up a little bit. I'll turn up the volume a little bit. So it turns out just the lamps are out. Now this uses 6 28 volt lamps, 3 on each meter, and they're wired in series. And it picks up the power off of these 2 white leads for the bridge rectifier right here. And it sends AC up here to the back of the meter board, and then right up here you can see where the 3 and 3 more lamps are, but they're all in series. It gets about 120 volts AC in here out of this huge power transformer, and then there's the 2 big filter capacitors, and then here's the amplifier board right here. So here are the pre-drivers down here and the driver transistors right here, and then it's hard to see, but way down here are 4 of the big TO3 power output transistors. You can almost see them if you squint through the fan. You can see the rounded part of one of the TO3 transistors down there, the other one, and then one right there and one right there. That's one channel, and then the other channel sits right down here. But the amplifier actually is working. This is just one of the 2 power boards, and then the other power board is back here. But anyhow, there's an internal look at the Ampzilla. So I'm going to ask my customer if he wants incandescent bulbs to be replaced, or if he'd like me to replace it with some LED lights. So the reason that the meters weren't working is because down here on the bottom there are 4 switches to select the gain: plus 30 dB, plus 20, plus 10, or 0 dB. And so in the 0 dB mode, then it would read accurately. 0 dB would be 200 watts RMS into 8 ohms. But because none of those switches were depressed, we weren't getting any meter movement whatsoever. Anyhow, hopefully I'll have an answer for you, hopefully tomorrow, and have some parts ordered and get this Ampzilla up and running back in its full glory with some nice bright LED lights if the customer chooses to go that direction. And if not, we'll replace it with some good old incandescent bulbs. So I have the meter and backlight assembly out of Ampzilla. The meters are held in place by a couple of brackets, upper and lower, but they just screw onto the circuit board. So I went ahead and removed this so that we can try to get some light to illuminate. Let me backlight this real quick, because the meters are just basically see-through, translucent plastic on the back. And so it's got 6 incandescent bulbs in series, and they're 24 volt bulbs each. And so one of the bulbs burned out. And since they're in series, when one goes out, they all go out. They're number 757. I think they're actually rated at 28 volts apiece. So I'm going to go ahead and give the one I've got connected right here, give it some voltage. So there's 20 volts, and it's drawing about 75 milliamps at 20 volts. And so this would be 24 volts right there. The current really hasn't changed, about the same. And so if I take it up to 28 volts, I'm at about 90 milliamps right there. And so what I'm going to do is I've got some LED strips right here that came out of a industrial light. These are pretty high power LEDs, but we're going to drive them at a pretty low current. So I've got a couple of these strips, and this one I've just got bare leads coming off of it. So I'm going to go ahead and connect that to the power supply. and then I'll go ahead and increase the voltage. Pretty close to the same voltage per lamp, so I'm not going to put them all in series, obviously, and try to run it this way. But you can see they all light up pretty nicely there. And I would say to achieve about the same brightness as that one bulb, we're going to be looking at, so I'm feeding them with about 28 volts right now, and we're giving them about 15 milliamps for the entire strip. And so what I'm going to do is there's 11 LEDs in series in a junction, 11 more LEDs in a junction. So I've got 4 sets of 11 LEDs here. I'm probably only going to use 2 of them. And if I look at the length, approximately where the center of the bulbs are, I can mount one strip of 11 LEDs. Almost perfectly fits right there. And so I think I'm just going to go ahead and mount one strip here and mount one strip there. We'll demo all these old bulbs and sockets off the board, and so we'll need to run this at about 28 volts. So we're going to have to take the 120 volt source out of the power supply. Now it is center tap, so we're going to have about 60 volts to deal with. We'll send that into a full wave bridge rectifier, put a little output filter on it to keep a flicker away. Just a few microfarads is all we need. And then we'll use just a dropping resistor to get the current that we want for 2 sets of these LEDs. And so, like I said, right now I'm driving all 4 of these at about 15 milliamps. So it looks like we need probably about 4 milliamps per, which would give us 16 milliamps for 4. So we're going to only need to drive the 2 sets at 8 milliamps total. So we'll just have to figure out after rectification what the voltage should be theoretically, and figure out what value resistor we need to use to drop that, so the bulbs or the LED lamps only get 4 milliamps. So let's do a little bit of basic math and see if we can figure this out. So I just did a quick little test, and so driving these at 10 milliamps total, which is 2.5 milliamps per set of 11 LEDs, it requires 28.26 volts. And to drive at 6.25 milliamps or 25 total, 28.77. So we're probably going to be looking at a voltage of about 28.5 volts to get the required 4 milliamps per set to get adequate illumination. Okay, so as the circuit in the stereo goes right now, this is the secondary side of the power transformer, and it's 120 volts from here to here, and it is center tapped to a reference point. We'll just call that ground. And so they take the 120 volts, they rectify it into a full wave bridge rectifier, and they have a negative output and a positive output from there. And so what we're going to do is go from this ground portion and only one half of the transformer and feed it into another bridge rectifier with a filter cap, and then we'll choose the value of this resistor, and then these will be the LEDs. I only drew 4, but there are 11 per set, and there's going to be another set that's basically going to be paralleled. And so there'll be another set basically just paralleled across that. And so we're going to need to drop this till we get 4 milliamps right here. So it's going to be 2 milliamps per set basically. And so we just need to find out what the value of this resistor is going to be. So we're going to have 60 volts AC going into this bridge rectifier. And after it's rectified and filtered, theoretically we're going to see 1.414 times that voltage right here. So we should see about 85 volts to the input of this resistor. And so we need to subtract 85 volts, and we determined that the voltage is going to be about 28.5 volts. So we're going to have a voltage drop across that resistor of 56.3 volts. I might want to rethink this. I might want to put the 2 sets in series actually. That'll give us a less voltage drop, less heat generated by the drop-in resistor. So if we take 28.5 times 2 equals 57 volts. So 85 volts minus 57. We're only going to have a 28 volt drop in that case. And so to figure out what value resistor that we need to do in there, we just need to do a little bit of math. So basically it's just going to be voltage, 28 volts, divided by current, 0.004 milliamps, which means we're going to need a 7,000 ohm resistor, 7K. I doubt we'll find a 7K, but we'll probably find something close. So now we need to figure out 7,000 ohms, and it's going to be 28 volts, 4 milliamps. How much power is this resistor going to need to dissipate? Now to figure out the power in watts, we simply take the voltage and multiply it by the current. And so it says we're going to need a 0.112 watt resistor, so not even a quarter watt resistor. So if I find something near the 7,000 ohm range, I'll be able to just grab that put it in series after the bridge rectifier and the filter capacitor, and we should light the LEDs at 4 milliamps with both of those being in series, and that should give us more than adequate illumination. So let's go ahead and I'll mock up that circuit and we'll give it a try and see what we come up with. So I've decided I'm just going to build it and hope for the best. So I've got the bridge rectifier already mounted here where it's going to go. I just drilled 4 little holes in the circuit board, and then I'm just going to run some leads. These 2 are the AC input. So one will go over to this terminal and the other one will go to this terminal right here. And then there's currently a jumper here. We'll take that jumper out and we'll make one of these the positive output and one of these, actually this lead will go over to here, will be the negative output. And so we'll just have to slice one of these traces, put the resistor in there, and then this will be the positive output on this side and this will be the negative output on this side, and we'll have to run one wire to terminate the LED strip back to the other side to complete the circuit. And like I said, we'll just slice this trace, mount the resistor on the back side here so that it can be easy to access. If the customer would like it brighter or darker, I can change the value of the resistor, and then we'll just have to throw a capacitor from here to here or even from here to here, and the circuit's going to be done. So I'm just going to do it and we'll test it on the bench first. I'll bring it up on the isolated variac up to about 60 volts AC and see if it looks adequate, see if the brightness looks like we think it should look. So be back in a minute. Okay, so I've got it built, mocked up, ready to go. I've got my variac set at about 60 volts AC. Let's turn it on and see what we get. Oh, that looks very good. Let's measure the AC voltage. About 63 volts. Let's go to DC. I'll measure the voltage across both sets of LEDs. 57, pretty close to what we calculated. Supposed to be 58. So let me show you what I've done. So here's the 2 white input leads right here. Going to the AC input of the bridge rectifier. The negative output along with the filter capacitor. Negative. Follows this trace all the way over to here. That's the negative lead going to the negative input of the LEDs. Now the positive lead just comes over here, goes to the negative, through this series of LEDs back to this positive lead, which comes through the board right here. And so I've added a slice right there. Now I only had a 6.2K resistor, I didn't have a 7K. And then there's the positive return of the filter capacitor. So let's get one set of LEDs in the camera view. We'll turn the power on and off. You can see them fade out. So it's not a super fast or super slow fade out. There's no AC hum, AC ripple in these LEDs whatsoever. In fact, let's go to AC and we'll measure the amount of ripple on here. 0.04 volts of ripple on the LEDs. 0.02, the meter can't even really read it, it's so low. This has a resolution of about 0.02 volts. So with both LED strips, it's about 0.04 volts. And we've got 28.52 volts on that set, 28.55 on that set. So let's go ahead and put the meters back in it now and see what it looks like. Alright, so before I put this back together, I'm going to get my DEOXIT D5. And we're going to give these switches a little spritz of DEOXIT. And so by holding one of the switches down, it releases the latch on all the other switches. We can work them all very quickly in that fashion. And so let's go ahead and put the meters back in it, give it some power, and see what they look like. Alright, so here we go, 60 volts. Oh, that looks excellent. They're very well illuminated. There's really no dark spots. Ampzilla. Nice crisp white light. It just looks excellent. Well, so let's go ahead and reassemble this unit now, and we'll hook up the internal wiring, and we'll make sure that the meters actually work okay after that. So one thing I noticed that I want to take care of before I give this back to the customer, it's got these speaker terminals on the back panel here, and one of them is completely loose inside. So I'm going to need to try to take care of that. It's just the one that's loose. The other ones are nice and tight. So I want to go ahead and try to tighten these nuts up. It's going to involve removing the lug connector right here, and then folding it back down, and then removing the nut, tightening the inner nut, and then replacing the outer nut. Alright, so I've managed to get it tightened up. I got a little ratchet in here, and I've tightened the first one, and then holding down on the tab, torque it up really good. Then we'll bend the tab back around so the terminal can connect back to it. So now that one's all nice and tight. I had to completely remove the upper one to get access to the bottom one. So we'll go ahead and put the upper one back together now. So as you can see, there's a flat washer, a split washer, and then a nut goes on there. So we'll cheat a little bit. And so what I had to do is actually grab so I can get a good, there, it's getting tight. Yeah, we'll call that good. Next the lug goes on, and then one more nut. All tight. Bend that back. Attach the lead to it. Now that's ready to go. Now all I have to do is I'm going to cut off one of the 1/4 inch lugs, and I'm going to put a ring terminal on it and put it under one of these screws for the common from the power transformer. The common is this yellow wire down here. Now the two reds that come out of the transformer are the 120 line to line, and then this yellow one is the common, or the ground. And so these two terminals are connected to the common. And it is isolated from the main chassis. You see the earth ground right here, the PE ground, potential earth. It's attached directly to the case, the metal portion of it. But if you look back over here, you'll see these two that go to the speaker grounds are connected to the common from the power transformer. And I don't know if I can show it or not, but yeah, it's going to be hard to see. But there's actually a gap between this portion right here and the chassis ground, and it's held up with a rubber insulator in between here. So the earth ground right here, the chassis ground, is not electrically connected to the common ground. So this is actually floating through this big power transformer that they claim is a 1,500 watt power transformer. So I didn't know this until I looked it up, but this is actually a kit. This Ampzilla in 1978 was shipped as a kit, and you had to assemble everything yourself, including assembling the heatsink. Each individual piece has to be bolted up to the main frame on both sides. So everything in this was a kit. I could only imagine how it was to assemble this thing in the late 70s. It must have been just a blast to do. Anyhow, I'm going to get a ring terminal. We'll take out one of these screws. We'll put the ring in for the common. We'll attach the other white lead to one of the two AC, doesn't matter which one, and then we should be ready to go. So to facilitate the connection of the single white lead to the common, I went ahead and made up an adapter that gives me a 1/4 inch ring terminal to a 1/4 inch spade lug. And so what I did is I put a piece of 12 gauge solid copper in here out of a piece of Romex. I crimped both sides of it, and then in addition to that I soldered both ends of it in there, so it's very tight. It's not going to come loose. So now we'll just go ahead and zip this out. Now we can just plug our terminals right onto here, and then we'll be ready to go. Aren't analog meters just the best? Well, I certainly hope you enjoyed this video on the repair of the Ampzilla replacing the incandescent lamps with LEDs. If you enjoyed this video, please consider making a donation on my YouTube homepage with the PayPal donate button or at paypal.me/norcal715. Don't forget to subscribe, like, and ring that bell to get future notifications. Remember, with your help, we can keep these things out of the landfill and out of the recycle bin. Everybody have a great day. Thanks for watching. Bye-bye.